So what's this?
The capsule.
Capsule, and this is the and medulla and they're specifically called the pyramids. And part of the cortex comes down here in between, called the columns. And this is the renal papilla at the tip, right? So most of the glomeruli are out here in the cortex, okay? And remember, they look a lot like islets of Langerhans, so make sure you look. But you'll see a lot more of these, Bowman's capsule and glomeruli in the kidney slide than you will islets of Langerhans, because islets of Langerhans are not very common, they're only 1%. Okay, and then you have these varying lengths of nephron loop, or also called the loop of Henle. In cortical nephrons, they can just come a little bit into the medulla. In the juxtamedullary nephrons, which means it's near the medulla, they have long loops of Henle, and they may come down almost to the papilla here. By the time the urine gets to the papilla, it's a done deal. Before then, it's a filtrate, and we'll go over what happens there. And then we have the minor calyces, and they join to form the major, and they join to form the renal pelvis. And then this would be the ureter. Now here you can see two of them. I frankly don't know this one. I gotta look that up. This is called a cortical nephron. Everybody? And this is the juxtamedullary nephron with a very long loop of Henle. Okay? And let's start here. The glomerulus. Okay? It's called Bowman's capsule, or the glomerular capsule. And it has two layers. It has a visceral layer, and it has a parietal layer. Coming in is what? Afferent arteriole. What, and leaving? Efferent arteriole. And which is larger? Afferent. So what does that do to the pressure here? It increases it. So there's a filtration pressure, we call it. So things are being pushed out of these are called glomerular capillaries, and they're being pushed out. So the first step in making urine is a filtration step. And what forms the first layer that it has to get through? What are they enclosed in? Capillaries. So we have to get through the capillary wall. Okay? And what's that going to filter out?
Proteins.
Nope.
Blood cells.
Yeah, all the formed elements, okay, especially red blood cells, white blood cells, okay? Then these are called fenestrated capillaries, by the way. So what does it have to get through next?
Basement membrane.
The basement membrane. Then that filters out what?
Large proteins.
Large proteins. And then we have these podocytes here, okay? And they have these little filtration slits. And what does that filter out?
Small proteins.
Smaller, medium-sized proteins. So what we wind up with here, out here in this space, capture space, is basically like plasma, but very low in proteins. Okay. But we still have a lot of other things like sugar, glucose, and amino acids. Do we want to lose those? No. So the next part we're going to come to, I feel like the paparazzi is really...
You are very popular.
is the proximal convoluted tubule, right? And here's the proximal convoluted tubule, right, Alex? He's paranoid that I don't know his name. So the proximal convoluted tubule, okay, wherever it is here. I'm not sure which one it is. I think it's this one here. What kind of tissue is it in the proximal convoluted tubule? Simple cuboidal with microvilli and also lots of what we're going to do, what step is going to take place in the proximal convoluted tubule? Absorption, reabsorption, you could call it, from the proximal convoluted tubule back into the capillaries, peritubular capillaries. So after the efferent arteriole, we have peritubular capillaries, and we may or may not have vasa recta, which are long looping capillaries. Okay, so what's going to be reabsorbed? In the process of reabsorption,
Water.
Okay, a lot of water, some ions. Those are electrolytes. What else? What don't we want to lose again? Sugar, glucose is going to be reabsorbed, and amino acids, and the rest of the proteins. Okay, so those are going to be reabsorbed into those peritubular capillaries, so we don't lose some of those things. Lots of water is being reabsorbed too. In the descending limb of the loop of Henle, and I hope I have that right. This is the descending limb. When we get down here, we have simple squamous. Okay. Oh, by the way, you didn't tell me what else is important here for reabsorption. Is this all passive diffusion?
Oh, there's a lot of mitochondria.
Mitochondria, because there's some active reabsorption here going on too. And for people that have diabetes, the problem is they have so much glucose in that filtrate that they can't reabsorb it all because there's not enough carriers, because the glucose is being transported by carriers, and you run out of carriers, they get saturated. So that's why glucose winds up spilling over to the urine. Okay, and here we have this thin, simple squamous in the medulla. And here we go. This is a good one here. This is the cortex, remember, this is the medulla. This is very concentrated in salt. So that strong osmotic pressure, it pulls water out of the proximal, out of the descending limb here. Simple squamous here, a lot of water comes out again into the capillaries surrounding this area. Around here we have those vasa recta, looping capillaries. In the ascending limb, there is it's basically water impermeable, or at least most of it is, and it pumps sodium chloride out after transport. And that makes this very concentrated. That's what helps pull the water out in the descending limb. So the sodium chloride pumped out by active transport in the ascending limb makes this very concentrated. Then we get to the distal convolute tubule. What happens a lot in the distal convolute tubule? Secretion from the peritubular capillaries into that tubule. And what kind of things are we going to secrete?
Lactic acid.
I suppose we could.
Yeah.
I don't know. I don't know. I'm not sure about that. But, what else? What other things?
Oh,
Acid in general. Hydrogen ions. Because what do we have to do with the blood?
Balanced pH.
Yeah, we have to keep the blood pH about 7.4. And to do that, we can get rid of extra hydrogen ions. One of the ways we get rid of extra hydrogen ions is by putting them into the urine. Urine pH. Do we know what the urine pH is? No, it varies from 4 to 8. 4 to 8, from acid to basic. So that's a huge range when you consider each unit is tenfold. Okay, so huge range. So we can get rid of extra hydrogen that way. What else can happen there?
Get rid of nitrogen.
Get rid of nitrogen-containing waste. That's a major function of the kidney, because the nitrogen-containing wastes are toxic. Can you name some of the nitrogen-containing wastes?
Protein.
No. It's a breakdown product of protein that we're getting rid of.
Okay.
Okay. But there are things like ammonia,
Oh, yeah.
urea, okay, creatinine. Okay. So those get secreted in there. What else happens there? Is there any reabsorption going on here? And drugs, various drugs also gotten rid of there. Also reabsorb what? In varying amounts. Under hormonal control.
Water.
Water, okay. What's one of the things that controls water reabsorption? Anti-diuretic hormone. So if you haven't been drinking enough water, then we're going to reabsorb a lot of it back into the bloodstream, okay? So keep the blood volume up and the blood pressure up. And the antidiuretic hormone can act on the distal convolute tubule and collecting ducts. Okay. What else is reabsorbed sometimes? Under hormonal control. Sodium. What's the hormone? Huh? Aldosterone. So we can have varying amounts of sodium reabsorption in exchange for potassium, and water's going to follow the sodium. So those will help maintain the blood pressure too. So if you've had lots of water to drink, then you don't have the ADH, and it goes on through. If you haven't had much water, you reabsorb it. Okay. Also, let's look back here. Notice this. This is supposed to represent what? Okay, this is the distal convolute tubule, or some people say ascending limb of the loop of Henle. What did your teacher call it? Do you know? Did he talk about the juxtaglomerular apparatus?
Yeah.
What did he say was a part of it? Oh, well, okay, well, I'm just going to go ahead and do it my way. Okay. So this is the afferent arteriole, and we have these modified smooth muscle cells here. Okay. And here we have the distal convolute tubule, and we have macula densa here. This is going to monitor like the solid concentration and volume. And if the volume drops too low, the solid concentration drops too low, the macula densa cells act on these modified smooth muscle cells to make them release a certain substance called renin. And renin is part of what we call the renin-angiotensin 2 pathway. And I give you a big handout on that you don't have to memorize. Okay? But it leads to, for example, aldosterone being secreted. And that causes sodium to be reabsorbed and water follows it. That restores the blood volume and concentration. It also has other effects, like makes you want to drink more water, maybe ADH is going to be, et cetera. So there's a whole bunch of things that happen. So that will restore the blood volume. Now, what if the blood volume and blood pressure is too high? What substance is released? Something from the heart. Atrial natriuretic peptide. He may or may not have talked about that. Okay. And so that can, if you have too high a blood pressure, that can help you. It is just the opposite of what renin does. Okay? What have I left out? So by the time you reach down here, it's a done deal. It doesn't change anymore. And then the rest of it's just kind of collecting it, right, and storing it and